Okay, we're going to look now at the Pythagorean theorem a little bit more and how it's used for distance. We've kind of talked about the Pythagorean theorem as far as finding the side of a triangle, but now we're going to kind of look at it from a distance point of view. So let's take a look here at review a little bit. We have a triangle, which this is a right triangle. And we know by the theorem of Pythagoras that we talk about that the side of a triangle represents a square, and there's another square. And when we add both those squares together, they're going to end up to fill the hypotenuse square. Well, the problem is if we put the way this is on a coordinate plane, these two leg squares will line up with the coordinate plane. See, the hypotenuse one won't because it's off to an angle. So that's where it causes a little bit of a dilemma. So when we look here at this, we can see that this side has a measurement because it runs along the side of the triangle right on top of the coordinate plane. It's 1, 2, 3, 4 units. So we can measure that because it actually takes up 4 squares. We can do the same thing with the height where it measures 1, 2, 3, 4, 5. So that measures 5 squares. So we can do that part. But when it comes to the hypotenuse will be cutting through the middle of squares. So we won't be able to do that. But we can use the Pythagorean theorem where a squared plus b squared equals c squared because we know what this is and we can find the c by using the Pythagorean theorem. So let's take a look at a couple of points here. I have a point here at 1, 3, and then I have another point at 4, 6. Now, when the points are connected in a line, though, we can connect these points as they are now and show a right triangle. So I'm going to draw a right triangle here. Sorry guys, wish I could draw a better one. Okay, so there's my right triangle. Try it again. That's better. Okay, and on our right triangle, we can find this distance of C by knowing what our A is and what our B is. We can see that A is a measurement of 3 squares and B is also a measurement of 3 squares. So we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. We're going to plug it in and find and evaluate what's happening for C. So we'll have 3 squared plus 3 squared, which equals c squared. 9 plus 9 equals c squared. And then we have that 18 equals c squared. Well, when we take the square root of 18, we'll find out that roughly that this works out to be 4.24 approximately. Now, at first glance, you might not agree with that. You might say, well, that angle there, that looks like it went through 3 boxes. Well, let me kind of prove it to you. Let me grab this angle here, and let me also grab that little blue triangle that I made, and we're going to group them together. And I'm going to move it out of the way here and rotate it and kind of see it along the coordinate plane itself. Well, I can see from corner to corner it measures 1, 2, 3, 4, and a little bit more. So that 4.24, that approximation, is correct. That's exactly what it would be. Even though when we looked at it over here, when it was sitting here, it didn't look that way to us. It looked like it measured 3, but because it's not going through the middle of those squares, it's actually a little bit more. Okay, we're going to go on to another problem again, but first let's take a look at how this is related and how the distance formula is derived from the Pythagorean theorem. We know that a squared plus b squared equals c squared. Well, we can also know that when we take the square root of c squared, we know that that will give us c. When we take the square root of this side without knowing what it is, this is where we're transpiring. It is square root of a squared plus b squared. Now, we also have to understand what a squared and b squared represent. If I look at the triangles here, I know that this is the side of the triangle we'll call A, that represents that square. Well, on a coordinate plane, these will have x values. If I take the difference of these x values, they will give me the measurement or the distance between those x values, and that will be represented by A. The same is true for the B. I will have height values, a difference in height on the triangle. this location on the ordered pair and this location on the ordered pair. If I subtract those, that will give me this distance. So with A representing x minus x and B representing y minus y, I can take this and substitute it in and get the following just by putting its replacement in. I know that then this is going to represent distance, the distance of the sea. How far is it between these 2 points? And that's what we're trying to do. So let's take a look. Let's do a problem with just points, but not actually getting the diagram to look at. So we're looking at the points 3, -1, and 4, 0. Well, let's circle the y coordinate so that we can kind of keep an eye on that. So again, we know from our Pythagorean theorem that a squared plus b squared equals c squared. So a is going to represent the difference in the x values. So I have a 3 and I have a 4. And if you can imagine yourself on a number line, if you're standing at 3 and you're trying to get to 4, you're going to go one spot. So we're going to say 1 squared. And 4 take away 3 is 1, so that works out there. We'll do the same thing with the b. If I'm standing at -1 and in order to get to 0, again, that is one spot. Or the difference between these two is 1. So we're going to place that there. We know that 1 squared is 1. 1 plus 1 is 2. And then when I take the square root of 2, I'll get a long number, but it's basically 1.41. That's our approximate measurement for C. So we can do it without looking at a graph as well, as long as we know what goes where. Well, let's do it all from the beginning with everything all together. We're going to graph, find the distances, and we'll use the theorem to help us out. So let's plot these points. First we have -2, 3. So -2, +3 goes right there. We have -1, +1. And we have +2 and +3. So we'll get those points on the graph. And hopefully you guys can visualize that this represents a triangle. So let me draw some lines to connect our triangle together. There we go. So now we can see our triangle. Now when we're looking at the triangle, we can see that only one side we can tell the measurement, right? We can tell this distance. Well, this distance here represents 1, 2, 3, 4. So we could measure that distance. Now we can't see the distances of these other ones, but we know that each side of this represents a little triangle. There's one triangle there. That's represented by that hypotenuse. We have another triangle over on the other side as well. We do a little dotted line here so that you can see the triangles and see where they're coming from. So we're going to try and find the hypotenuses of these two triangles. We're going to start out with these 2 points first, which is this side. And it's -1, 1 to +2, 3. So remember, we said we're going to circle the y's. And remember that our formula is a squared plus b squared equals c squared. And then the difference from -1 to 2 is 3. This is 3 spots to get there. And we can kind of see that, isn't it? 3 spots, 1, 2, 3. And then the y's to get from 1 to 3 is 2 spots. And again, we can see the side measures 2. So that's our c squared. So we'll get 9 plus 4 equals c squared. And then we're going to get that 13 is c squared. And then we'll find the square root of 13. And we find that c is approximately 3.6. So we know that this side of the triangle here, this one here, is going to represent 3.6 approximately. Now we're going to take a look at the other one, and we're going to use these 2 points, the -2, 3 and -1, 1. And again, our x's are circled. And we have that a squared plus b squared equals c squared. And again, the difference in the x's from -2 to -1 is 1. And we can see that here. There's a difference of 1. Plus, from 3 to 1 is 2. And again, we can look at our diagram here and see that there are 2 spots. That's where that comes from. And then we'll work this out. 1 squared is 1. 2 squared is 4. Equals c squared. And then we have 5 equals c squared. And then we'll take the square root of both sides to find out what c measures. And we find out that that's 2.24. So this side here measures 2.24. So that's how we use the Pythagorean theorem to help us find distances.